Have you ever tasted a sourdough loaf and wondered how it got that tangy twist? It's not just time, it's chemistry, and it's happening in the dark, in the silence of a fermenting loaf. Fermentation isn't just about making yogurt or beer. It's a hidden world of chemical reactions that transform simple ingredients into complex, vibrant flavors. Every bottle of kombucha, every jar of kimchi, every slice of cheese, it's all about the unseen dance of microorganisms turning ingredients into something new and delicious. The next time you taste a fermented food, remember, you're tasting a chemical symphony, one that started long before you opened the jar. So what exactly are we talking about? Fermentation is like a kitchen where microbes take the reins, transforming simple ingredients into complex, layered flavors through chemical alchemy. These tiny organisms aren't just causing bubbles. They're breaking down sugars, proteins, and fats into acids, alcohols, and gases, creating the building blocks of flavor. It's a slow, deliberate process, where time and temperature play a role in shaping the final taste, sometimes revealing unexpected depth and nuance. From sourdough to kimchi, fermentation is an ancient art that's still unlocking new layers of flavor chemistry, one microbe at a time. So next time you taste a fermented food, you're tasting a chemical symphony, each note shaped by microscopic life, and each bite a story of transformation. You might think fermentation is just about making beer or kimchi, but it's actually a chemical symphony that shapes the taste of everything from cheese to coffee. Every time you taste a fermented food, you're tasting the results of complex chemical reactions. Some you can feel, others you can't, but they're there, quietly shaping your palate. By understanding fermentation, you start to see how food and drink aren't just made. They're transformed, sometimes even reimagined by the invisible chemistry happening beneath the surface. And the more you learn, the more you realize that the flavors you love may have been shaped by ancient, invisible processes that still influence what you eat today. Let's rewind to ancient China, where rice and wild yeast met in clay jars. These early fermenters didn't know it, but they were unlocking the secret to umami. Fast forward to the Middle East, where dates and milk transformed into yogurt. This was the first step toward understanding how microbes could turn simple ingredients into something complex and delicious. In 17th century Europe, beer and bread were more than just staples. They were the foundation of a growing curiosity about microbes. Scientists began to wonder, what makes these drinks taste so different? By the 19th century, Louis Pasteur's work on fermentation was both revolutionary and controversial. He showed that microbes were the key, but some resisted the idea that invisible life could shape flavor. Today, we've moved from mystery to mastery. Fermentation is both science and art, but its roots are still in the same invisible, transformative power that ancient cultures first discovered. Imagine you're making lemonade, but instead of sugar, you use oranges. The juice starts to bubble and smells funny. That's fermentation, like a secret party in your juice. Tiny helpers called microbes come to the party. They eat the sugar and make new flavors, like a science experiment you can taste. These helpers don't just make bubbles. They make new stuff, like acids, alcohols, and even some weird, amazing flavors you can't get any other way. Fermentation is like a flavor alchemy. It turns simple stuff into something totally new, and you get to taste the magic. So next time you eat yogurt or kimchi, remember, it's not just food. It's a secret science experiment, and you're the lucky taste tester. So, to start, you need a vessel. Something that can hold your ingredients and let the magic happen without leaking or breaking. Think of it like a cozy little home for your microbes. Then, you need your ingredients. Whether it's cabbage for sauerkraut or milk for yogurt, they have to be fresh, clean, and ready to be transformed by the microorganisms. Next, you have the starter culture, like a pinch of sauerkraut, or a spoonful of yogurt. This is the first step in introducing the right microbes to start the fermentation process. Now, you seal the jar. It's important to leave some space for gas to escape, but not so much that it leaks. A tight lid or a cloth cover can work, depending on what you're making. Finally, you let it rest in a warm, dark place. The microbes will start their work, breaking down sugars and creating acids, gases, and new flavors that will develop over days or weeks. Now the microbes start to eat the sugars in the liquid. They break them down into simpler molecules like glucose, which they can use for energy. As they metabolize the sugars, they release byproducts like ethanol and carbon dioxide. These compounds are what start to change the flavor and texture of the food or drink. These chemical changes happen slowly over days or weeks, and they're what make fermented foods taste so complex and unique. The process isn't just about making alcohol or acid. It's about creating an entirely new flavor profile through chemistry. Every fermentation is a chemical symphony, and the microbes are the maestros orchestrating the transformation. Now we get to the clever twist, the moment when fermentation really starts to shine. It's not just about breaking things down, it's about building new flavors. Certain microbes, like lactic acid bacteria, don't just eat sugar. They produce byproducts like lactic acid, which then change the pH and set the stage for new chemical reactions. These byproducts can create esters, alcohols, and other compounds that are responsible for the complex, layered flavors we love in things like cheese, beer, and kimchi. It's like a chemistry experiment in a jar, where the microbes are both the chefs and the chemists, transforming simple ingredients into something entirely new. And the best part? These reactions can be fine-tuned by controlling temperature, time, and the microbes themselves, giving you a recipe for flavor that's both ancient and scientific. At the heart of fermentations, microbes are like tiny chefs, breaking down sugars and proteins with enzymes that rewrite the flavor blueprint of food. These transformations aren't random. They're guided by the microbe's own genetic code, which determines what molecules they can produce and which they can't. For example, lactic acid bacteria turn sugars into lactic acid, which not only preserves the food, but also gives yogurt and kimchi their sharp, tangy edge. Meanwhile, yeast produces ethanol and carbon dioxide, creating that effervescence in beer and the crispness in sake. What makes fermentation so fascinating is that it's not just about the microbes. It's about the chemistry they unlock, shaping taste in ways science is only beginning to understand. So, here's the thing. Fermentation is like a really intense, slow-cooked stew. You throw in all these ingredients, let them simmer for days, and by the end, it's like the whole thing has been reimagined. The microbes are the chefs. They're not just cooking. They're rewriting the recipe, adding layers of flavor you can even taste unless you're paying attention. It's like when you take a classic dish and let it age in a secret cellar. Every day, it gets better, deeper, and more complex, almost like it's learning to taste itself. And just like that, you've got a flavor profile that's not just good. It's almost like it was made by a team of chefs and scientists working together in perfect harmony. So next time you taste something fermented, think of it as a slow, secret collaboration between nature and human curiosity. Sweet, sour, tangy, and totally unexpected. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.